We have a sphere of radius 5 feet containing grain with depth of 9 feet. The grain inside weighs 6 pounds per cubic foot. Find the amount of work required to empty it through the top of the sphere. So the important stuff here to remember is that the radius is 5. The depth, although, a sphere with radius of 5 would have from the bottom to the top would be, of course, 10 feet, but it's only filled up to the 9 feet. And since the grain weighs 6 pounds per cubic foot, and notice that this is the weight, so this is already unit of force. I don't have to multiply it by 9.8. Find the amount of work required to empty it through the top of the sphere. Okay, so let's go to the next page. And here I know that if I have, so let me just put this circle in here. And so let's say that this is looking like that. And so one slice of this is going to be looking like a very thin cylinder. So volume of one slice is going to be pi r squared times the thickness. So the surface area of a circle, one slice, is a circle, pi r squared times its thickness, delta y. And of course, since I'm working with y in here, this r, I have to somehow change it back to y. What is it that, how can I do that? Notice that in here, if I put my sphere on 0, 0, the center of the sphere on 0, 0, and claim that this is 0, 0, so this is my x, this is my y. If I do that, I can claim that x squared plus y squared equals 5 squared. That was given to us as the radius. And if I solve for x squared, I get x squared equals 5 squared, which is 25 minus y squared, and x equals to square root of. I'm not going to write plus and minus because in this case it's geometry. I only need the positive root, square root of 25 minus y squared. Okay. And so this is my radius. This is my radius, 25 minus y squared. So let me go ahead and go to the next page. And so we said volume of one slice, v equals pi r to the second. So we said radius is 25 minus y squared times delta y. And pretty soon this delta y changes to dy. Okay, we were given that the grain weighs 6 pounds, so per cubic feet. Okay, so let me change column and write that the grain weight is 6 pounds per cubic feet, and the distance each slice of grain has to travel. Let me go to the previous page. Okay, so each distance, notice that if the slice is in here, has to travel, and of course this point right here is 0, -5. This point right here is 0, +5. So if the slice is up here, if I say 5 minus y, that makes sense. But does that make sense for if the slice is down below? And the answer is yes, because let's say if this slice is at -2, minus minus 2 is +2, so that there's going to be that extra 2 units that this slice of grain has to travel to make it to the 0, and then the rest goes up. So going back here, actually, let me go to the next page and say, so work equals from -5, and we said in the beginning that the height of the grain is 9. So I'm going from -5 to 4. -5 to 4, which is going to be a total of 9 units. The volume that was pi r squared, which is 25 minus y squared, delta y, I'm going to put a dy at the end. Then we multiply that by 6, that is the weight. And we said that the distance that every slice has to travel is 5 minus y. All right, let's pull out the 6 pi and take the integral from -5 to 4, 25 minus y to the second times 5 minus y dy. And I just wanted to be sure I plugged that into my TI-84, and it gives me, well, let me just put equal. I'm going to put lots of digits. According to my calculator, 15649.8438. That's good enough. So 15,649.8438 foot-pound is the work required to empty the grain from the top of this container. Email me if you have any question. Thank you.